Okay, so we've been talking about working with our variables and stuff. Let's put it back into our context of our fractions then. When we had a fraction like 18 over 30, we reduced that by dividing the top and bottom by the same thing. But as we saw earlier, we could use factoring. 18 factors into 2 times 3 times 3. 30 factors into 2 times 3 times 5. We can cancel out a 2 and a 3, leaving us with just 3 over 5. 18 over 30, both could be divided by 6 if you wanted to, which is the same as 2 times 3. When we throw in the variables, let's do 6x to the 5th z over 8x to the 3rd y squared z to the 5th. Generally, it's easier dealing with these algebraic fractions if I treat the numbers and the variables separately. Now, I'm going to do it the long way first with everything together, and then I'll come back and show you if we separate them. 6, of course, is going to factor into 2 times 3. X to the 5th is 5x's, and then we have the z. 8 factors into 2 times 2 times 2. X to the 3rd is 3x's. Y squared, 2y's. And z to the 5th is 5z's. If we cross off what's in common, we cross off a 2. Any other numbers? No, so for our number, it's going to be 3 over 4. Where'd the 4 come from? 2 times 2, very good. For x, we can cancel out 1, 2, 3 of them. What's left? X to the 2nd. Now I'm going to do y next because alphabetically that comes next. Is there anything to cancel with the y's? No, so that's just going to be y to the squared and it stays on bottom. How about the z's? 1 cancels out and we're left with z to the 4th, and that's on bottom. That's the long way to do fractions with variables, algebraic fractions. Now, if we look at what happened here, and if you need to, you can always go back to that. Just write out all the factors and cancel out and put everything else back together. But looking at this, there's a shorter way to do it. If we can reduce the numbers, assuming we can take 6/8 and reduce it to 3/4, the variables then can be done in a much shorter way. So if the x to the 5th and the x to the 3rd, we subtract. 5 minus 3 is 2. How do we know that the x squared goes on top, though? Yeah, it was positive. 5 minus 3 was a positive 2. Also, the bigger power was on top of the fraction. Now, for the y, there was nothing else there, so the y squared has to go on bottom. For z, I think of this as z to the 1. Well, you'd either do 1 minus 5 is negative 4, which tells us that z to the 4th had to go on bottom. Or we can see, where's the bigger power, top or bottom? Bottom, z to the 5th. So the z is going to go on bottom, and then the difference between 1 and 5 is 4. So let's do 27, a to the 5th, b squared, c to the 8th, over 18, a squared, b to the 5th, c to the 7th. Now, I'm going to deal with the numbers and the variables separately. 27 over 18. To reduce that. Now, first of all, some of you might be looking at saying that's an improper fraction. Let's make it a mixed number. Why can't we do that? Because it isn't just 27 over 18. It's 27 with all the variables, a to the 5th, b squared, c to the 8th, over 18, a squared, b to the 5th, c to the 7th. When there's an algebraic fraction, when there's variables involved, we cannot split that into a mixed number, ever. So if there are variables in the fraction, it will always stay improper. Because we don't know the values of a, b, and c. This might not even be an improper fraction. The top might still be larger than the bottom. But anyway, what can we reduce both 27 and 18 by? 3, 9. 9 is the bigger number, so let's do that first. 27 divided by 9 is 3. 18 divided by 9 is 2. So we have 3 over 2. So for the numbers, we have 3 over 2. For a to the 5th and a to the 2nd, the difference is a to the 3rd. Top or bottom? Top. The bigger power was on top, so a is going to go on top. For b, is this going to end up on top or bottom? Bottom, and it'll be b to the 3rd. Very good. Difference between 2 and 5 is 3. C, top or bottom? Top, and the power of, 8 minus 7 is 1, so just C. We don't have to put the 1 on there. So let's have 75, x to the 8th, y to the 3rd, z over 45, x to the 5th, y to the 5th, z to the 3rd. Where am I going to start? Reducing 75 over 45. Both of those can be reduced by 5. Let's divide by 5 gives me 15. 75 divided by 5 is 15. 45 divided by 5, 9. Are we done? No. Both of those can be divided by 3. 15 divided by 3, 5. 9 divided by 3, 3. Now again, we cannot make that into a mixed number because there's algebraic variables involved. That's going to be 5 over 3. How about the x? It's on top because 8 is the bigger power and that's on top. And the difference between 8 and 5 is 3. So x to the 3rd on top. Y? Bottom to the 2. Good. The bigger power is y to the 5th. It's on bottom. The difference between 3 and 5 is 2. Z? Bottom 2, yes. Think of that as z to the 1. The bigger power is 3, which is on bottom. The difference between 1 and 3 is 2. So that's it right there. So that 15 x to the 9th, y, z to the 3rd, over 18 x to the 8th, y to the 5th, z to the 3rd. Where do I start? So 15 and 18 can both be reduced by 3. 15 divided by 3 is 5. 18 divided by 3? 6. So the numerical part is 5 over 6. Let's fill in the variables. Where's the x go? Top, and it is x to the 1, so just x. 9 was the bigger power, is on top, so x goes on top. 9 minus 8 is 1, so x to the 1 or just x. Y, bottom, power of 4, good. This is y to the 1. 5 is the bigger power, and it's on bottom. The difference between 1 and 5 is 4. How about z? Cancels out. 3 minus 3 is 0. Z to the 0 is just 1, so it doesn't do anything. So that's just 5x over 6y to the 4th. Not so bad? Well, let's look at this one then. Where do I start? All my numbers, 35 over 49. What can both of those be divided by? 7. Okay. 35 divided by 7 is 5. 49 divided by 7 is 7. So my numerical part is going to be 5 over 7. Now technically I should do my variables in alphabetical order. Which one should I do first? B to the 5th. Anything happen with that? No. So B to the 5th is just going to stay on top. What would be next? C. And it's going to be just bottom. It's going to stay C. Nothing to cancel with. What would be next? D. Where's that going to go? Top or bottom? Bottom, because the bigger power is on bottom. And it'll be what power? 1 or just D. Right? Then what? N goes top. The difference between 8 and 5 makes it 3. So there we are. 5b to the 5th, n to the 3rd over 7cd. Are we having fun yet? You did a great job of faking sincerity there. I'm impressed. Let's have you try one on your own here quick. I'll pause this and let you do that one in your notes. Okay, start with the numbers. 48 over 64. What can we do with those? Reduced by 16. Good. 48 divided by 16 is 3. 64 divided by 16 is 4. So up here, our numerical part's going to be 3 over 4. Then what? X to the 3rd on top. 5 is the bigger power, so it's on top. 5 minus 2 is 3. And then y on bottom. 4 was the bigger power, so it's on bottom. The difference between 3 and 4 is just 1, so just y. So 3x to the 3rd over 4y. Very good. Now, one of the things we did with our numerical fractions, we took something like 2/5, and we said if we need to rename it to 20ths, what do we do? Well, we'd have to do 5 times what makes 20? 4. So what do we have to do to the 2? Times 4 to make 8 20ths. We said 8 20ths and 2/5 have exactly the same value. They just look different. The reason they have the same value is what we multiplied by here. 4 over 4 is just 1. Well, with our algebraic fractions, the same type of process is going to apply. Let's say we have 3b squared over 7a. And I need a denominator of 21ab. So looking at this, what do I have to multiply 7a by to make it 21ab? Well, what would I have to multiply 7 by? 3. 7 times 3 makes 21. How about the a? Do I have to modify the a? No, that's just an a. Do I need anything else? I need the b. So what I'm multiplying by to turn a 7a into a 21ab, I'm multiplying the 7a by 3b. So what do I have to do on top? Multiply by 3b. 3 times 3 is 9. B squared times b, b to the 3rd. So 9b to the 3rd. So if I have 7xy squared over 10z, and I need a denominator of 50 x squared z squared. Again, I'm going to start with the numbers. To turn the 10 into the 50, what do I have to do? Times 5. Now, before I look at the z, I got an x over here. How do I get the x squared? Well, times x squared. There are no x's here, so I got to do the whole thing. Times x squared. Anything with the y's? Nope. How about z? Yeah, I'm going from a z to a z squared, so I have to multiply by z. So to get from 10z to 50x squared z squared, I multiplied the 10z by 5x squared z. So the top has to get multiplied by 5x squared z. 7 times 5 is 35. X times x squared, x to the third. Y squared doesn't change, and the z doesn't change. Now, if you're struggling to get this part here, what you could always do is this. Take this denominator, 50x squared z squared, and divide by the old denominator, 10z. 50 divided by 10 is 5. Nothing to divide the x squared, and z squared divided by z is z. So let's take 8b over 9a squared c. I need my denominator to be 36 a to the third b squared c squared. I'm just going to do this. I'm going to divide it out. 36 a to the third b squared c squared over 9 a squared c. What am I going to get? Walk me through this division. 36 divided by 9, 4. A to the third divided by a squared, a. How about the b's? B squared. There's nothing on bottom to work with it. And c stays. C squared divided by c is just c to the 1 or c. So I multiplied to get from 9a squared c to 36a to the third b squared c squared. I had to multiply the 9a squared c by 4a b squared c. So I have to multiply the top by 4a b squared c. 8 times 4, 32. A, nothing to multiply by, so just a. B to the third, b to the third, and c. Let's have you guys try one here. We're going to have you do 15xy to the third over 16z to the fourth. And we need it to have a denominator of 32 x y squared z to the fourth. Tell me what that numerator is going to be. So to get from 16z to the fourth to the 32x y squared z to the fourth, what do we multiply by? 2 for the variables, x, y squared. The z to the fourth and z to the fourth are already there, so we don't need to do anything to the z. So now on top, we have to multiply by 2x y squared, which is going to give us, perfect, 15 times 2 is 30. X times x is x squared. Y to the third times y squared is y to the fifth. So 30x squared y to the fifth over 32x y squared z to the fourth. Any questions? Okay. Well, some other applications of our fractions, to get back into the numbers again, more of the real world, we could look at fractions within word problems. For example, you might have Pete earned a gross pay of $42,000 last year. He paid taxes of $14,000. What fraction of his gross pay was his taxes? Well, literally this is just creating a fraction and reducing it. So we're saying what fraction, the first thing is to figure out what goes on top and what goes on bottom of the fraction. The key that we're looking for is the words out of or of. In this case, what is this going to be out of? Out of the gross pay. So the gross is going to go on bottom. And his taxes are the other part of it. So what fraction are his taxes out of his gross pay? So you said the 42 goes on bottom with the gross. That is perfect. What goes on top? 14,000 is the taxes. Now I go to reduce this. I told you before that the first thing I look for when I reduce fractions is tens, because you just have a zero. Well, in a special case like this, you can look for hundreds or even thousands. How do I know that they both divide by 1,000? Because there's 3 zeros at the end of each. So 14 divided by 1,000 is 4, or 14,000 divided by 1,000 is 14. 42,000 divided by 1,000 is 42. Now what can both of those be reduced by? 7. Okay. 14 divided by 7 is 2. 42 divided by 7? 6. All done? No. They'll both still be divided by 2. 2 divided by 2 is 1. 6 divided by 2? 3. So his taxes of $14,000 is 1/3 of his gross of $42,000. He got my cheap. Sorry. Anyway, let's say that we're looking at a production run in a factory. Production for the day is 1,650 parts. If 125 are found to be defective, what fraction are defective? So here, what's going to go on top and what's going to go on bottom? Top will be well, what fraction are the defective? It's implying what fraction out of the total parts are the defective. So top will be the 125 defective. Bottom will be 1650. What can both of those be reduced by? 25, okay? 125 divided by 25 is 5. 1650 divided by 25 is 66. 5 over 66, can that be reduced? No. 5 over 66 is the fraction. That's it. Now, similar to that, let's say that we have 800 parts produced and 40 are defective. What fraction of the parts are good? What's a little bit different here? Well, what's going to go on top, what's going to go on bottom is still the 800. We're looking for what fraction out of all the parts. Is the 40 going to go on top, though? No. What's going to go on top? (800 minus 40). If we want the fraction that are good, if there's 800 produced and 40 are defective, 800 minus 40 has to be good. What's 800 minus 40? 760 over 800. Both of those can be reduced by, we both have a 0. Let's divide by 10. So 76 over 80. What can they still be reduced by? Not everybody at once. 2. 38 over 40. Are we done? Nope. Still divide by 2. 19/20ths. 19/20ths are still good. A little bit different way of looking at things. Let's look at cars on a lot. Of the cars on the lot, 24 are blue, 18 are red, and 20 are green. What fraction of all the cars are red? So in our fraction, what's going to go on top? We're focusing on the reds. That's the 18 that are red. What's going to go on bottom? We have to add them all up. Very good. So it's going to be 18 over 62. Now what? Reduce them. What can both of those be divided by? Well, they're even, so they can be divided by 2. 18 divided by 2 is 9. 62 divided by 2? 31. So 9/31 is the fraction that is red. Out of 36 students in a class, 12 of them fail. What fraction pass? By the way, the rate in this class is much better than that, just so you know. For those of you getting there. What fraction of them pass? So in our fraction, we're looking for what fraction pass. So on top is going to be the students that pass. What's going to be on bottom? Total students, right? That's going to be the 36. What goes on top? What number goes on top? 36 minus 12. If 12 failed, the others hopefully passed, right? So 36 minus 12 is 24 over 36. And both of those can be divided by 12. 24 divided by 12 is 2. 36 divided by 12, 3. So 2/3 pass. Any questions? Good. Well, just to see how much you remember. In your notes, do that one for me quick. So, of course, 2/5 to the power of 6 can be broken down into 2 to the power of 6 over 5 to the power of 6. 2 to the power of 6 is 64. 5 to the power of 6? Perfect. So 64 over 15,625.
Now, are we wrong if we don't do that middle step?
Nope, if you just take it straight to this, you're okay. How about this one? 28x to the 5th, y to the 3rd, z to the 4th, over 42x squared, y to the 4th, z to the power of -2. Give that one a shot in your notes. Okay, so where do we start? Inside the parentheses, what can we do? Okay, well, first we should reduce 28 and 42 can both be divided by 2, 7, or 14. Giving us 2 over 3. Then what about the x? So x to the 3rd on top. The bigger power's on top of the 5th. 5 and 2 have a difference of 3, so x to the 3rd on top. Y goes on top or bottom? Bottom, because the 4 is the bigger power and it's on bottom. Y to the 1, or just y, because 4 and 3 have a difference of 1. Z goes on top, because 4 is the bigger power, and it's z to the 3rd, because you think of this as z to the 1. The difference between 4 and 1 is 3. Now what? It's a negative power, so we're going to flip this over. The 3y goes on top, 2x to the 3rd and z to the 3rd go on bottom. And this is still the power of 2. And then 3 squared is 9. Y squared is y squared. 2 squared is 4. X to the 3rd squared is x to the 6th. Z to the 3rd squared is z to the 6th. Let's throw just a little bit of a loop in here. Just what you wanted, right? What would we do here? Prayer won't help you. What do you need to do? We're going to multiply inside the parentheses first. So 7 times 4. Crying won't help you much either. It might make you feel better for a while. 7 times 4 is 28. Because we're inside the parentheses here. We're doing those two have to be multiplied. There's nothing to do inside this one. There's nothing to do inside this one. So I'm combining the two because they're multiplied. So I'm doing 7 times 4. It's 28. A to the 5th times a to the 2nd is a to the 7th. B times b to the 3rd, b to the 4th. Good. And this is all still to the 3rd power. So 28 to the 3rd power is big. Perfect. 21,952. A to the 21. B to the 12. The reason I wanted to do that is so you can see here, when I'm doing a to the 5th times a squared, it's 5 plus 2 to make 7. When I'm doing a to the 3rd to the power of 3, it's 7 times 3 to get 21. How are we doing? Better than a sharp stick in the eye? Not so much? Okay, well, there is a new quiz due tomorrow. That is Wednesday at 11:59 p.m. There's new Wednesday, that's the 16th. There's a new homework due Thursday at the start of class. Those of you here in Rice Lake, I have some tests still to hand back, somebody that corrected them. Those of you at New Richmond, I've got a couple of you that have emails, messages in my inbox with test corrections. I will get those in the grade book in the next couple days. With that, we do have the computer lab next door open here if you want to start on your quiz or work on your homework, either one. New Richmond, again, the library should be open for you if you want to work there.